Translocation. Plants transport organic compounds from sources to sinks in the phloem. Phloem loading is the process by which sugars enter the phloem. Sugar produced by a source is actively loaded into companion cells, and then it diffuses into phloem sap. Osmosis in. The active loading of sugar here creates a high solute concentration in the sieve tube, which is this connection of sieve cells. This causes water to be drawn from the xylem into the phloem by osmosis. This increases hydrostatic pressure. Because water is incompressible, when it enters the sieve tubes, it presses on the cell walls and increases internal pressure near the source. This prompts mass flow, which is the movement of water and materials down a pressure gradient. Because so much more water is up here, there's a higher pressure here than there is down here. So water and materials will move down the pressure gradient. It basically forces the phloem sap to move away from the source and towards the sink, which is the area of lower pressure. Phloem unloading. At the sink, the companion cells unload sugars from the phloem and into the sink. This can be active or passive depending on the concentration of the sap and the sugars. Depending on the sugar concentrations. As sugars leave the phloem and go into the sink, the solute concentration of the sap at the sink decreases because there's less sugar, meaning the sap becomes more hypotonic. This prompts osmosis out because the decreased solute concentration in the phloem causes water to be drawn back in to the xylem by osmosis. That in turn decreases that hydrostatic pressure. The decrease in water in the sieve tube allows lower hydrostatic pressure near the sink, which lets sap flow from the areas of high hydrostatic pressure by the source to areas of low hydrostatic pressure by the sink. That's a pressure flow mechanism because phloem sap always flows from source to sink. Though sources and sinks can flip, it will always flow down hydrostatic pressure gradients.